This video is primarily let's see, go here and now on the board, there and then, but number. The system of the church is made via proof, but this the here and now is an access, and there and then of the levels down the future event. Yeah, there's three graphs in trace, there and then future. um, Left, middle, right, left, middle, right, left, right, middle, left. On one axis, the So that was basically what it before, but I will come to that later. So what's today's video about? Today's video is about the kind of NAMD, kind of something what I am, what it is to be, I became. But it's basically about slicer. So I'm gonna give you the framework in mind, but this is basically about the NSIGII quantum radio for human rights. Which is human rights framework, quantum radio system. So it's going to be a jamming, anti-jamming system because you can jam something. So wait, before it has to be done, that's complete. So I'm introducing 5 things, 8 things that have to be formalized properly. 8 things to formalize properly, and 8 things today will make me afraid for the rest of the day if I put into AI and it can build the radio system. But it's gonna have to work for me. That's why I know about radio system. So radio systems, you have a radio system, and the radio system will have a button. Now you have in my radio model, my model radio system, you have A to I, 0 to 9 mapping. A0, A1, A2, A3, A4, A5. Now, broadcasting, a feature of all A0 is anything at 0 is reserved. So A0 is reserved, B0 is reserved, C, D0 is reserved, etc. So all the zeros are reserved. Now you have A1, 2, 3, 4, 5 that are channels. Now these channels are people's stations. A1, B6, I9, all those stations, non-reserved stations. You can use those stations. You can have a space with a station. So you can allocate. First, you gotta have a broadcasting system. So the broadcasting system works by if I have a radio channel, and the radio channel is a map of a dry system. You have A1. Now, let's see what I'm saying. You have what am I saying? Utilizing radio frequencies. So you go to utilize radio frequencies. Let me try to show you guys this. Utilize radio frequencies as channel bank via a trident tripartite network topology. So it's basically latitudinal, basically meaning latitude means crossing the equator from the up pole, from the northern pole to the western pole, and the rest of the is east and south to west, and longitudinal means so you get latitudinal, which is east to west, west east, in a bidirectional system, and you get longitudinal, which is no, you get latitudinal, which is northwest, west to east, based on backwards propagation, backwards propagation of the radio system. But the radio system of the radio frequency are basically AM, amplitude modulation, or frequency modulation. The main difference between amplitude modulation is the old measured in hertz, but the amplitude is basically how far up the wavelength goes, how far from the north the frequency bounces up down. Like so, kind of like the space between the axis, this based on the sine wave. The frequency is the frequency basically can go with the frequency as modulation. But it goes to have the system represent the space, which is based on the up and down movement of the systems. Basically, what is the sine wave and how periodically the sine wave occurs and occurs via Doppler shift framework of drift. So the Doppler shift is just one example I'm using because if a car speed them and the air compresses over the car, you hear it sound like similar to this. So basically, that's telling you that you hear, double shift. You have to make the sound because there's no cars here. But the double shift is basically an example of the compression of the band, and the compression of the band can uncompress and decompress, which is basically why inflation and deflation matters. The second thing, the fourth thing here that says here, the NSIGII rubber band mod. Now, the rubber band is so important. It's so important. This cannot be eliminated from the radio system. It cannot be. It's so important. The rubber band, even rubber band, and the band has a rubber. This is a rubber band. Doesn't want to stretch it and the rubber band is intact unless there's some kind of force that breaks them, that tears it. But it wants to push back. It wants to bounce back. Property. I'm just about the physical. I'm about the bounce properties of the rubber band because the band is the channel, and that channel is elastic. So my elastic systems are why they made the system of a band channel because you have the electronic neutrino model, which is my model of radio frequency. This is the rubber band model. So if I think on rubber band and I spin in my hand, I spin in circles, my model rubber band is it's in the shape of my hand. And that shape is what the system has to keep there. But if I then take it and spin it up and down like this, it should be elastic. Should elastic spin. If I stretch the rubber, is this the elastic model for rubber band? A rubber band. Now, a rubber band is elastic, and that's why the system, my radio frequency system is elastic. So it's basically elastic system for security. But putting the button spinning up and down wasn't really the up and down position. I'm saying the spin up and spin left are two different states, two different topographic states that move into a lattice. That means they're used for different order operations. So lattice gives you order. That means you're performing different operations on lattice, and that's what I said like that. So you gotta have a spin up, spin down position. What I'm going with this is basically, is it a particle? Or is it a wave? Is it a message packet? Or can distinguish between the polarity of the sequence of bytes, that are based on the polar how the message is incoming. So it's basically a frequency modulator of its own kind. And it's elastic frequency modulation. The beauty thing of this elastic system is that the system is naturally heterogeneous homogeneous and respects the wavelength of the the Earth's curvature in the day, night time, the date and time of the day. It respects the kind of framing behind me. So the drift vectors, the rotation, displacement, and evolution. So basically, the eight things here that hypothesis covers. So the hypothesis quantum radio systems cover basically SIGI for the phone call. So every system has a quantum radio. So this is what the system does. Basically SIGI is a human-raised protocol. N for number, S for Sarah, I for indigo, G for gold, I for India, I for India. And you have the human framework. And the more you stretch the band, the more you can snap. But that goes unconsensual. And when the band snaps, guys, it basically means someone's tapped into your immune system, and you should be looking for threats now. One of you is hostile or something like that, or internal, external, internal, based on the color coding of the tripartite graph. So you have three colors. You have red, yellow, red, three tripartite, red, orange. Three particles. So if it's orange, that means danger, light danger. Against it's red, you have danger. If it's yellow, you have yellow. You have warning. If it's lime, you have light warning. If it's, and these are two colors of warning. So light warning is lime, yellow is warning. And this is you're gonna have another color. You're gonna have green and lime green. So again, let's use the color lime. This is something. You're gonna use lime red, lime green, and lime yellow. And you have all these three colors that dictate whether a system is in danger or not, based on the warning of structure. But the system basically uses double shift as drift vectors to model the balloon electron field via electron. Now, let's use the slide here. So I don't know this slide. You get quantum electrodynamics, quantum gravity, strong, weak. You get electromagnetism, gravity, graviton. But this is saying that that affected by electromagnetism. Photons. Now, beautiful of this. Yes. Someone got it right. So you get electromagnetism and get quantum electrodynamics. This is the framework I'm proposing to use via my electronic neutrino model. You see, you cannot show the gravity. Yes, it's a weak force, and gravity is literally the thing that annoys me. Because why don't you hear gravity? No, why aren't you a weak force here? The W the force carriers the vector they have a mass so if I was something that oscillates, that thing contains energy. That thing contains magnetic energy, and then it's being transferred. That's what's oscillating. It isn't vibrating or oscillating. Because oscillating goes back and forth, back and forth. So it's thinking of about if it's going to be a resonant duplex and can't probably go one way, can probably go both ways. It's electromagnetic, and that's what electromagnetic is. This is something that over an easy adaptive current that can go electronic magnetic that goes up and down, left and right. But the spin of the rubber band is isotropic, so it's a shear state of a system. It's a state of equilibrium of force. And the system, what I'm trying to explain here, my point is, guys, that quantum electrodynamic system and electromagnetic system, photons that operate that has a wave photons and wave photons and photons which can be in two states, can be in electron states, which is electrons. Electron state. So you can model a photon. A photon can be in just a pure light state, electric light. Some kind of photon, such as electron light, or electromagnetic state, electronic state, usually like a wave. It has a mass, and this mass is mapped to a Bloch sphere. Now, I don't want to talk about this informally. I don't talk about it formally, but that's my evolutionary reason. Electron, listen, usually don't have mass, but they. That's wrong. That's wrong. Look, I usually don't have mass. None of them have mass. But I'm saying there's something that has mass. What is that? Something that has mass. Basically, it should be. I should look at my electrical conversion tables for this. Matter has mass because it matters. Quark lepton. A quark has mass, right? No. I'm trying to find something that has one. Atom, yeah, composite particle. Look at them. Yes, Higgs boson. Higgs has mass, but these are elementary particles. So I should know what these are before we start going over this. I don't even know anything. Shows my knowledge of the system around me. But that's why we could always matter. So the mapping of the Bloch sphere is not necessary. So it's not. It is a system of quantum electronic dynamics based on electronic properties and called traits. And these traits dictate the spin up and spin down when there is dimension. Before and the opposite system will be the opposite system. You have electronic system and you have magnetic system. And you can have things that either that can be in one channel, but if it's like a spin up and spin down, that means something else because the medium of confusion is different, basically. So that's why the I can't explain to you, but basically, because I do my other video. So you have the Bloch sphere quantum state of my different instrument, b squared minus 4ac. Now, b squared minus 4ac determines the polarity of a sequence of bytes based on the amplitude, the vector amplitude, and the drift vector amplitude, and the vector, how fast moving at an angle. Basically, the Bloch sphere has an angular drift b squared minus 4ac, which is equivalent to minus 4ac minus 90 degrees. 90 degrees. Basically, you're gonna have the four quadrants, which I call 90 degrees, 180 degrees, minus 180 degrees, 270 degrees, and 260 degrees, and you're gonna have the drift. Now, drift is basically an angular shift. You're gonna have something drifting away from me, from front of me. So if I'm zero if I'm the center of something, I'm on node, and if I move something away from me, and it's basically moving away from me, and it's moving straight away from me, like when I'm facing, it's drifting away, and it's drifting away, and that's basically a shift. But if it's moving away, it's moving to the side, away from me, and it's in front of me, then I know it's drifting orthogonally to other direction. But this is the measure. Then if you're moving towards me, I can measure the drift based on the compression of that wavelength. It's a block sphere model of a quantum radio state mapping for discriminant. The system has to respect its own isotopic nature before it's based on drift. Based on drift. B squared minus 4AC is the determinant of this based on rotation, displacement, and elevation in the 3D space of a Bloch cube. Oh, okay. So the Bloch theory has to respect the frequency of amplitude via distillation. Now, the distillation of a vector produces a channel, radio channels, because this radio channel is going to be in the phone call, like in a polyglottic phone call system, or how does NSIGII work? If I go to the video, I'll find it. Not now, But this is two people. Human speaking, three people. P for Papa. Via probing. So the balloon electromagnetic field, we talked about that. The electric neutron model, we talked about that. The rubber band model, frequency elasticity, and you get the alpha, the trident, the trident topology. So custom complete, this has to be complete. So this is the trident topology. It's not a gimmick. It's a rule system. So the trident topology is literally for time, hours, meters, seconds. Everything comes in seconds. So everything must have to have the trident topology. So hours has minutes, has seconds. Three things in one. Doesn't matter what it is. If it's two things, it's gonna be incomplete, and if being incomplete, it's gonna fuck up the system. So the trident topology is a three-channel of an actual trident, which is a trident ruling that determines what gets voted in, voted out, or vected. You know what I'm saying? What frequencies basically get voted in, voted out, and vected if it's blocked. But it can happen autonomously. So this is a system for the for the human beings, but you have to charge that until you need that. Namji. But that's what I'm saying. So what does this say here? The drift theorem. So b squared minus 4ac has b when the change in b is less than 0, you have a distribution of the frequency that based on the drift. Now the drift is basically v squared minus t squared uh, um, uh, um, so if you have three piecewise functions that map to each other, the three you have basically what I'm saying is you have three latitudinal basically the models have three longitudinal piecewise functions that map to each other. So we're gonna have a piecewise like b squared minus 4ac equals 0. B squared minus 4ac is less than 0. B squared minus 4ac is more than 0, and they have 0 based on another system. So you have the one that's flipped it. So you have three systems. So if this one's basically filtering out something such as the drift, the ones dealing with the electricity to what is the quantum, what is the mass of the message, or because a particle, or characterized as a wave, just something that should probably as a wave, which is what the protocol is really at, because which is a wave that emits, channel, whether it's so you can stop tapping it and tapping out. So it actually comes with three quantities: yes, no, and maybe. Yes, no, and maybe. And that's the first quantity. That's the first goal of this system. I'm gonna try and draw it out on my notebook, but I'm very bad at math, so let me try and do it anyways. For me, myself, and I. So you have three functions, and these functions map to each other in a heterogeneous original order. So let me just try and draw it here. Yeah. So here you have, I think it's the you have, I don't know, you have, I don't know, I'm writing my book, yeah, I'm writing like, make like a color. I feel like I should go back to school. So you have a message. So the message, basically, you gotta understand the protocol is a wave, and that wave is a rubber band, and the rubber band has two models. You're gonna have a circle and a circle, and this is a static system. Um, Snapping the block sphere, and this is the wave. So the messages propagate as waves, but to the observer, they're static. The messages propagate as a wave because it's electromagnetic, but they to the observer, there's no message, there's static signals. You just hear what's need to be heard. They are that's the first piecewise functor to yeah, just go drift. They run for radio systems. Uh, observer. So you have this model here. So this is a velocity drift, drift velocity. So you have so the system can either be either distill. The first step is to distill drift distillation of I got the solution already of this I got my video on it. I'm going to check the videos of a radio system of a radio signal via pi r squared. How do I do a pi r squared? 2 pi r to pi r squared. Via color coded. Basically, that's the video I have already. Made a video already, and so you're gonna have observer A. So basically, you're gonna have hello. So you're gonna have a digital wavelength. You're gonna have a digital wavelength. So digital wavelength will be like something like this. Let me just put it here. Digital. So you get a digital here. Now that just about digital, this is a digital signal, and you're gonna have the longitudinal signal. So you're gonna have. I'm trying to model this properly, guys. You're gonna have two waves. You're gonna have three waves, three kind of wavelengths here. But you're gonna try. So you have a longitudinal wavelength. Wavelength, longitudinal goes up and down over the north and south pole, and you have north, south, and you have a latitudinal, which goes left or side to side, or left or right, side to side, up and down, and you have a block sphere, block sphere. Just trying to do this now. So this is a radio static system here. This is radio static. So this is basically this represents matter, and the matter is the message packet. And you have the wave. Now the wave will be rotating. Basically, I really do the maths and everything I need to do. I just need to make the radio system, but you have to, I have to get all the videos to put it into the system so I can have it my operating system. But it's gonna allow you to know where the radio system and know where it is. That's the policy there. You have to know where it is, know what it's doing. Tell you what it's doing precisely, actually. So here the drift from, which is system one. So again, move away drifting. So transforming the soul or this one to drift. This is basically a join. You have a mix. Well, basically, because the operator that's the sub, that's just meat. That's just join. This is basically string. So this is not this is a full song, which is a lightweight, lightweight. Uh, so so wait, yeah, yeah. So you got to cue the blocks wave here, the wave. You asked me about the problem. You have the message packet as or blocks the mother system. So you're gonna have two systems. Sorry, how do I model this? Variable. One, two, three. Um, so this one work. It has to work, guys. Just so, but I know it does work. It's not it doesn't work. It just has to join and meet, and the join and meet has to be, based on. So electron neutron. Basically, you have to hold. Electrons don't have a mass. I'm not saying yes. What you say? Because they don't have a mass, but they hold something. Neutrons hold something. I'm pretty sure they do, but they don't have any mass. So I'm saying the thing they hold is mass. Is that the message has mass, but they don't hold it. Electronic systems, electron neutrino model is what I'm proposing for this coordinate system. And I'm trying to get it sorted out, basically, if you guys want to join in. But, I've never built a quantum radio system in my life. I've never, but it goes after something complete before it jams. Complete jam. Complete something, complete the system, make it perfectly unhackable. Unacceptable. A message with immediately unacceptable, and then with unacceptable message, they can if the message picks up any signal, will then jam those other systems, and that's a very procedure for the micro system. It has to be secure by carrying out its own ordeals first, own operations without getting jammed in the process, and after a set period of time. Time is the second. Day and night can then jump on the signals and to carry on its own operations. Muhahaha, I've joined the guys. I'm the first masquerade. I'm so proud of myself. Thank you guys, Nambi. What did you do?